Okay, the video that we're making today goes along with number one of our homework activity that the students were supposed to complete it. And with this item, it's a story problem, and you can tell where I've already annotated it a little bit using the cubes method. I'm going to start off by reading the question out loud. It says, Jack enlarged the photo so that its area was 41 1/4 square inches. If the area of the enlarged photo is about 2 3/8 times the area of the original photo, what are some possible dimensions of the original photo? Okay, so using the cubes method, I went back and I circled my key numbers. I circled 41 1/4. I also circled 2 3/8. Then I underlined the question. The question says, what are some possible dimensions of the original photo? Then I boxed some math action words. Now, these might not be a lot of action to some of these, but they're important words that give me an indication of operation as well as what my answer is going to look like. For instance, I put a box around area. I put a box around about, possible, dimensions, and here I put a box around times and area. Now, when I think of area, I think of the formula area equals length times width. So when we have a number such as 41 1/4 square inches, and that's the area of an enlarged photo, then we know that photo, the length times the width of that photo, is equal to 41 1/4 square inches. Now in my mind, I think about some of the common sizes that photographs are usually printed on. I know today students got their school picture proofs back, and they have order forms that will let them buy pictures such as 8 by 10 size. The area of a photograph that's 8 by 10 would be 80 square inches, or 80 inches square. A photograph that's 5 by 7 would be 35 square inches, or inches square. So when we look at 41 1/4 square inches, it's going to be a little bit bigger than a 5 by 7, but quite a bit smaller than an 8 by 10. But it gives me an idea of what this is going to look like. Now where it says the word about, that tells me that with about and possible, that my answer is not going to be an exact answer. This problem is more concerned about whether or not I know the process and I can come up with dimensions that are possible answers. Now, when it says that 2 3/8 times the area of the original photo, that 41 1/4 inches squared is 2 3/8 times the area of the original photo. One way to look at this, and I'm using in my mind trying to solve a simpler problem before I work on this complex problem, which is some of our math practices. If I were to have a watermelon that I wanted to enter in a fair, or say not a watermelon, let's say I have a pig, and that pig, when I get ready to enter it into the fair, let's say it weighs 100 pounds. 100 pounds. And if I were to say that that pig is twice as much, weighs twice as much as it did when I got it, how much did it weigh when I got it? Well, I know that 100 divided by 2 is 50, and 100 is twice 50. So if I divide 100 by 2, I get 50. So if I divide 41 1/4 by 2 3/8, I can get the original area. I can get the area of the original photograph. So that's what I'm going to do. I'm going to write down 41 1/4 inches square divided by 2 3/8 inches squared. And once I get my answer, my quotient, that's going to tell me the size of the original photograph. And then based on that, I can come up with my dimensions, the length times the width. So I have two mixed numbers here, and what I'm going to do with these mixed numbers, I'm going to make these mixed numbers into improper fractions, and then I can solve them using the standard algorithm. I can say that 4 times 41 is 164 plus 1, 165 over 4. I can say 8 times 2 is 16, plus 3 is 19 over 8. Now when I divide fractions, I change the sign to multiply, and then I get the reciprocal of 19 over 8. So that's going to be 8 over 19. Now I'm going to do a little bit of cross-simplifying or cross-canceling, however you want to refer to it. I know that the greatest common factor of 4 and 8 is 4. I can get one group of 4 out of 4, and I can get two groups of 4 out of 8. 19 and 165 are what we call relatively prime. The greatest common factor of those two values is 1. So I can't do any cross-simplifying or cross-canceling there. Now if I have 165 times 2, I'm going to get an answer like this, 330. And 1 times 19 is 19. Now to take that improper fraction and to make it a mixed number, I'm going to divide 330 by 19, and my remainder will be my numerator. So let's see. I'm going to go ahead and work that out right here. So 330 divided by 19. So that's going to give me 17 wholes. I get 17 groups of 19 out of that 330. And my remainder, 7, is my numerator over 19. So I can get 7/19 of another whole. So this is going to be the original area. 17 and 7 over 19 inches squared. Now to find the dimensions of the original photograph, in my mind, I'm thinking it's going to look a little bit like this. And I'm going to make this an easy one for me. I'm going to make a whole number be part of my dimensions. I'm going to say that the width here, I'll say the width here, and because it says multiplying, I can make the width this way or that way. It doesn't matter. But I'm going to say 4 inches. And it's just 4 inches because it's the length. It's not inches squared. It's just going to be inches. So 4 inches will be the width. Now I got to figure out what the length is. I got to figure out what is the length if the size of the original photograph is 17 and 7/19 inches square. The way you figure that out is you have to divide, because L times 4 gives us this answer, then we're going to have to divide this answer by 4 to find out what L is, what the length is. So I would write this problem as 17 and 7/9 divided by 4, and that will tell me what the length is. And in this case, I'm going to go ahead and make this mixed number an improper fraction. 9 times 17 and 7. Since I know it's equivalent to 330 over 19 because I worked it out here, I'm just going to rewrite it down here. And I know that's like 4 over 1, so that's going to be 1/4. Now, 330 and 4, the greatest common factor would be 2. I can get two groups of 2 out of 4, and because I know that two groups of 165 is 330, I know I can get 165 groups of 2 out of 330. So now it's 165, because 165 times 1 is 165, over 19 times 24. Now let me put 19 here, 24 here. Placeholder. $465. 456, I misspoke. Now, oh, I see my mistake. I knew I made an error because I knew that my numerator was going to have to be bigger than my denominator, and I see that where I had reduced this down, this 4 to a 2, I accidentally wrote it as 24. So I know that's wrong. So I'm going to have to rework it just for a second. So 19 times 2 is going to give me 38. So I can change this out, make it 38. And then how many groups of 38 can I get out of 165? So I'll divide 165 by 38, and I can get 4. 4 times 8 is 32. 4 times 3 is 12, plus 3 is 15, 13. So this one, I can get 4 groups of 38, and then I'll have 13 38ths of another whole. So I could say that the length is 4 and 13 over 38 inches by 4 inches is the possible dimensions of that shape, of that picture. There was a whole lot of steps here. There was a lot of steps in this process, but eventually we got it done. I hope this video helps.